Hey everybody, Mr. Longo here, and we are going to talk about probability. A little introduction to probability. I want to give you a heads up and let you know that probability can become very difficult depending on how complex we want to make it. So understanding the basics is absolutely essential. So we're just going to start out with a little bit of vocabulary, and then we're going to talk about a couple of things today, and then we'll have to continue some other time. So an experiment is a situation involving chance or probability leading to results, which are called outcomes. And you probably are already familiar with a lot of this. It's flipping coins, rolling dice, spinning a spinner, grabbing colored marbles out of a bag. There's all sorts of different experiments we can have. An outcome is the result of one trial or an event, which is one or more outcomes. So that would be like you're flipping coins. Flipping coins is one of the events that you are doing. Now, a sample space is the set of all possible outcomes of an experiment. Now, that's going to be where we find our probability. We need to know the total amount of options that are possible. That's known as our sample space. Okay, and probability is the measure of how likely an event is. So we'll talk about all of that. So the probability of an event, usually we just, capital P for probability, and inside the parentheses is, what we're doing. And it's equal to success over the total. Now, total is going to be different for every different situation. So flipping a coin, rolling a die, doing a spinner, there's all sorts of different types of total. So it's the total possible outcomes, which is your sample space. Okay, and like I said, success is just, that's what you're looking for. So it's kind of easier to talk about this as we move along. So the first three examples we're going to talk about is just being able to identify what a sample space is. So our first example is flipping a coin. Well, you know what a coin is, and you know it's got heads and it's got tails. So your sample space is a head and a tail. But it also is two possible outcomes. Okay, you have two possible outcomes with that, a head or a tail. And it's important to know that. When you roll a six-sided die, your sample space is a 1, 2, 3, 4, 5, or a 6. Those are the only 6 numbers you can roll on a six-sided die. So rolling any one of those is, you have a 1 in 6 chance of getting. And then our last example, we have a glass jar containing 1 red, 3 green, 2 blue, and 4 yellow marbles. That is our sample space. But if we were to add all of that together, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 marbles. Okay, so that's very important to know. So you have to know your total amount of outcomes and how many are successes depending on what you're looking for. And that's the introduction to what probability is going to be. So we need to talk about the two different kinds of probability, and we'll do a couple examples, and then we'll be good. So we have theoretical versus experimental. Now, theoretical is, this is what the probability is mathematically. Experimental is you just have to run some experiments and then you just calculate your results. Now, the thing about experimental is it could be totally different for different groups. So if we were to just say take 10 groups of students and their job is to flip a coin 10 times. You might get one group that gets 7 heads and 3 tails. Another group might get 6 heads and 4 tails. Another group might get 2 heads and 8 tails. Experiments don't always give you the theoretical probability. So the theoretical is just what is the possible outcomes divided by your total amount of outcomes. So Flipping a coin. What is the theoretical probability? The theoretical probability is you have two sides, and your choices are either a head or a tail. So, what is the theoretical probability of getting a head? Would be 1 out of 2, because you have one head out of two sides. Okay? So you have one head out of two sides to a coin. So your theoretical probability is 1/2, which could also be written as 0.5, a decimal, which could also be written as 50%. Now, all of those are technically probabilities. Usually we go with 1/2, but all three of those are technically correct answers. Now, experimental. This group recorded 7 heads out of 10 tries. So what's the probability of getting a head? The probability of getting a head was 7 heads out of 10 attempts. So our probability, our experimental probability, is 7 over 10, also known as 0.7, which is also 70%. Now that's where you have to stop and think. Do you really think if we were to do this for every single group, you're always going to get 7 out of 10? And the answer is no. Like I said, what if another group tried this and got 2 out of 10? And if you were to do this over and over and over and over again, your probability will be pretty close to 50%. But that's the difference between theoretical and experimental probability. Okay? So why don't you try this next one really quick, pause the video, give it a shot, and see what you come up with. And then we'll talk about it, and then we're done. So another group of students rolls a 6-sided die 10 times. And they roll a 2 3 times. So what's theoretical and experimental? For theoretical, you should have said there's only 1 2 on a 6-sided die out of 6 possible sides to the die. So your probability is 1 over 6, which is 0.167, also known as 16.7%. Okay? So that's your theoretical. Now, this group just happened to roll a 2 3 times. So if they rolled a 2 3 times out of 10 rolls, then their probability for the experimental probability was 3 in 10, also known as 0.3, which is 30%. Now again, just because this group rolled a 2 3 times doesn't mean it's always going to happen. You could have another group that doesn't roll a single 2. Does that mean the probability of rolling a 2 on a 6-sided die is 0? No, of course not. So experiment isn't always very accurate, and it's less and less accurate the smaller amount of times you do it. Now, there's a pretty good chance that if you were to roll a 6-sided die 10,000 times, that you would be pretty close to 16.7%. And it's still not going to be exact, but there's a pretty good chance you'd be close. Okay? So anyway, that's it on experimental versus theoretical probability. This is Longo, and I'm out. See you, bye.